Hi folks, welcome to the video on 3.5, which is dividing polynomial. So we're going to start off the way that we've been starting off pretty much every class, which is what we know and what's new. And so when we're looking at dividing polynomials, let's figure out a case when we don't really need to use it first, and then we'll talk about why we might need it at different times. Okay, so what do we know? We know that if we have f of x equals x cubed plus 4x squared minus 12x, and if someone said, hey, I want you to factor that for me, even though it looks a little scary at first, one thing you might notice is that every single term has an x. In other words, we can factor out the x and kind of see what we're left with after that. So if I take an x out of every single term, I'll get an x squared, because x times x squared gives me x cubed, plus 4x, because x times 4x gives me 4x squared, minus 12. Okay, so this is a technique here called looking for the greatest common factor. And that's actually a really nice thing to do to check for at the beginning of a complicated factoring problem, okay? But what we can do now is we can use what we know about factoring to factor x squared plus 4x minus 12. And so what we get is we still have the x, but when we think about numbers that add or subtract to make 4, but also multiply to make negative 12, we might realize that we have a 2 and a 6. 2 times 6 gives me 12, and I can do a difference between 2 and 6, or I can subtract them to get a positive 4. Now that does mean that the 6 is going to be positive, and the 2 is going to be negative, so that I get 6x minus 2x gives me 4x, okay? So we did the GCF, and then we did factor, the trinomial, okay? So we did the GCF, and then we did factoring the trinomial. And so what we end up with here, right here, we're going to learn a word in the next section, and it's called a linear factorization of a polynomial. And all that means is you broke down that polynomial into its linear factor. Okay, every single factor here is linear. We have an x, we have an x minus 2, and an x plus 6, and those are all linear factors. Okay? Now let's take a look at what's new. So in this case, we have f of x equals x cubed minus 6x squared minus x plus 30. And if we think about what happened in our previous example about what we know, let's look for that GCF. So is there a term that is in every single one of these x cubed minus 6x squared minus x plus 30? And the answer is no, there's no GCF. And so when we're looking at a case where there's no GCF, then what we want to be using is using division, because that will help us factor. And actually, let me say that will help us find the linear factorization. So in a case where there's no GCF and the power, well, let's say the degree, and the degree is greater than or equal to 3, then we want to use division to help us find the linear factorization, okay? So that's where we're headed in this section. We're going to take a look at 2 types of division. The first type is something called long division. And I want us to see that because I think long division is familiar for us. But really where we're going in this video is we want to be able to use synthetic division to help us in the problems in section 4.6, okay? So we're gonna learn the long division, but ultimately I want us to be able to use synthetic division to help us answer the question. So let's take a look. What is long division, okay? So question number 1, is 2 a factor of 45? And some of you who are pretty good with your basic number senses might say, no, 2 does not go into 45, and you would be correct, okay? But what I want us to do is kind of write this in a more traditional long division way and use that to help us understand what we're really meaning when we say it's a factor of 45. So to check if 2 is a factor, we can say, does 45 divide 2? And so when we use long division, we set it up like this. We put the 45 inside. We have the 2 on the outside. And then we think about how does 2 go into the first digit, or 4. So 2 goes into 4 2 times. And then 2 times 2 gives me 4. Then I'm going to subtract, and I'm going to get 0. And then I bring the 5 down. So how many times does 2 go into 5? And you realize, oh, it only goes in twice. And then 2 times 2 gives me 4. And now when I subtract, I get 1. Now, unlike in elementary school or middle school when you learned long division, I don't want us to keep going. I actually want us to stop right here, okay? And the reason why is we're gonna label a few of the things here with some vocabulary, okay? So here comes the vocabulary. This 45, okay? So this 45, we're gonna label in yellow. And the 2, we're gonna label in orange. The 22, let's go with green. And this number all the way down at the bottom, the 1, we're gonna label in pink, okay? So let's see what all these different parts of long division are. So the number underneath that, the long division symbol, the 45 in our case, we call that the dividend. Okay. So the thing underneath the square root, or not under square root, under the long division is called the dividend. The number that is on the outside, where like the 2 is, that is called the divisor. Okay, so that's the same as the 2. The number at the top that you get at the end is called your quotient. And so that's our 22, or the number in the green. And you do your long division a few times, you subtract, and when you get to the end, the number on the bottom, the one in the pink, is actually our remainder. Okay. And so what that means is when we take 45 and we divide it by 2, we get a remainder of 1, okay? In other words, we could say that 45 equals 2 times 22 plus a remainder of 1, okay? So again, 1 is the remainder, 45 is our dividend, 2 is our divisor, and 22 is our quotient, okay? So the really neat thing is, if you use long division, if at the end you have a remainder, okay? That means that whatever you're dividing is not a factor of your dividend, okay? So if there is a remainder, then the divisor is not a factor of the dividend. Okay? So if at the end you get a remainder, then the divisor is not a factor of the dividend. Okay? That's a really, really important concept there. If you divide and there's a remainder, then the divisor is not a factor of the dividend. But let's see what happens if we try the same process with example 2. Is 5 a factor of 45? So really we're thinking 45 divided by 5. And let's use our long division here, 45 and 5. And so I noticed that 5 does not go into 4, okay? So I put a 0 there. 0 times 5 is 0, and when I subtract, I get 45. And how many times does 5 go into 45? And it's 9. And so when I subtract this time, I get 0. And so what this means is that 45 equals 5 times 9 plus 0. And the part that I want us to focus on is this part, the 0, okay? Or that 0. But that 0 means there is no remainder, okay? So if there is a remainder, then the divisor is not a factor of the dividend. But if the remainder is 0, then the divisor is a factor of the dividend. Oops. Okay, so if the remainder is 0, then the divisor is a factor of the dividend. Okay. So in general, that's what we want to think. That if this remainder, let's put this down here, okay? So if the remainder is 0, then the divisor is a factor of the dividend. Otherwise, it is not a factor, okay? And since our goal is to factor things, we really want to identify things that are factors, right? That makes sense for us. If we do division and we get a 0 at the end, that means we will end up with a factor, okay? So let's try it out. Is 3x minus 2 a factor of 6x cubed plus 11x squared minus 31x plus 15? So I know things got complicated real fast from the last page, right? But let's set this up using the same process. So I'm going to go ahead and draw my long division symbol. On the outside, I've got 3x minus 2. On the inside, because that outside piece, remember, this is my divisor. And so now I need to find the dividend. And so this, just like before, is our dividend, okay? So we're gonna use the same process here, except we're doing this with polynomial, okay? So what worked with just numbers actually also works with polynomials. So let's think about this first. How do I get 3x to be 6x cubed. Like, what do I multiply 3x by to get 6x cubed? Well, we can break it down, right? 3 times what gives me 6? Well, 3 times 2 gives me 6, okay? And then x times what gives me x cubed? Well, x times x squared gives me x cubed. So if I take 3x and I multiply it by 2x squared, I will get 6x cubed. And since my term is a square, I'm going to put it above the term that has a square. So 2x squared. And I'm going to take this 2x squared, and now I'm going to multiply it by 3x minus 2. So that's going to give me 6x cubed minus 2 times 2x squared is 4x squared. Now we got to be careful here because we are subtracting this whole thing, okay? So 6x cubed minus 6x cubed is 0. That's good. That's what you want. But then the next term is not 11x squared minus 4x squared. It's actually 11x squared plus 4x squared because it's a minus minus. So this is actually going to be plus 15x squared. Okay. Now I'm going to repeat the process. I'm going to bring down the 31x, so minus 31x. And now I'm going to say 3x times what gives me 15x squared. And that's going to give a plus 5x will get me to 15x squared. And 5x times negative 2 is negative 10x. Now, same thing here. I'm actually subtracting the whole thing, so I need to be super careful about my signs. And so 15x squared minus 15x squared is 0. And negative 31 plus 21, plus 10x gives me a negative 21x. And now I'm going to bring down the 15, okay? And we're going to ask ourselves this question all over again. 3x times what gives me negative 21x? And that's going to be negative 7. So I get negative 21x plus 14. And now I have to subtract the whole thing to see what I get. Well, the x's cancel out, but 15 minus 14 doesn't give me 0. It gives me 1. So we've got our quotient up here, but the more important part for us right now is that 1 at the bottom. And because, okay, so our answer is going to be, our answer is going to be no, this is not a factor, because when you divide 6x cubed plus 11x squared minus 31x plus 15 by 3x minus 1, the remainder is 1. Okay, the remainder is 1, so no, it is, no, it is not a factor, okay? So if you've seen the discussion board, you know that Val will very awesomely post videos about some of the questions you all might have. And I think one of them was about long and synthetic division. And there was a meme that she posted about like, oh, what happens when your professor asks you to use long division on a test? And I mean, just from this one example, you can tell it's kind of long and probably a very tedious process, okay? So that's why that joke is supposed to be funny, because this process is not very straightforward, all right? But it does make a little bit of sense when you compare it to what we know about numbers and how numbers work, okay? So what we're gonna do now is we're going to learn something called synthetic division, right? Let me scroll back down. We're gonna take a look at something called synthetic division. And what synthetic division is a slightly more efficient way to find a factor, okay? So let's practice this process with the same example we had in example 3. So we already know this is not a factor, but I want us to show how this process works and how some of the numbers we're going to see in synthetic will actually be the numbers we see in the quotient and the remainder, okay? All right, so here's how the setup goes for synthetic division. Instead of using a long division symbol, we have a smaller one pointing the other way, okay? So it's like this. And what we're going to do is next to this, we're going to take our dividend, and we're only going to pull the coefficients. So 6, 11, negative 31, and 15. And we're going to write them next to this little right angle we have. So 6, 11, negative 31, and 15. And if you have lined paper, you're going to skip a line and then draw a line. Okay, so skip a line and then draw a line. All right, now what goes inside of this little right angle that we drew? Well, we're going to take our 3x minus 2, okay, or we call our divisor, and we're going to think what number for x makes this divisor equal to 0, okay? So let's think about that. What number x makes this divisor equal to 0? Well, I can add 2 to both sides, and then I can divide by 3, okay? Super, super important that you don't turn this into a decimal and round, okay? You will 100% get the wrong answer if you turn these fractions into decimals and round. Sorry to be the bad news bear. But this number that we saw that makes that divisor equal to 0, that's the number that goes inside this little right angle thing. So we're going to put a 2/3 in there. And we got this 2/3 from our divisor, and we got these numbers from our dividend. Okay? And so now it's a question of adding and multiplying. Okay, so the first thing we're going to do to get this started, we're going to take the first number, we're going to drop it down below the line. That happens every single time. You take that first number, you drop it below the line. But it's the first yellow number. It's not the orange number, okay? Then you're going to go ahead and multiply those two, okay? So 2/3 times 6, well, that gives me 4. And now, after we multiply, we are going to add those two. So I get a 15. Okay. All right, let's try this again. So now that I have a new number below the line, I'm going to multiply. So 2/3 times 15 gives us 10. And then I'm going to add straight down. Negative 31 plus 10 is negative 21. And then, because I still have one more number left, I'm going to go one more time. 2/3 times negative 21 gives us negative 14. And then I'm going to add, as I go down, 15 minus 14 will give me 1. So remember how at the end of the other problem, I was like, that remainder is so important. That remainder, if it's a number other than 0, means that your divisor and dividend are not factors. Well, this, your very last number, is your remainder. So if we get a 1 here, that means the remainder's 1, which means that it is not a factor, okay? And so we know that it's not a factor. So in order to answer the question, we need to specify the quotient and the remainder, okay? So the quotient here is this green thing at the top, 2x squared minus plus 5x minus 7, okay? So here's what we need to do. We're going to take these three numbers, okay? Those represent the coefficients of a polynomial. So here's what they do, and I'm going to write these down here so we can take a look at them better. 6, nope, sorry, just kidding. So this first number right here, this is the constant at the end of the polynomial, so negative 21. This 15 represents the linear term, or the coefficient of the linear term. So the 15 is really a 15x. And then the last one here is really the coefficient for the quadratic term. So the 6 really means 6x squared. So let's write those out then. All together, we have 6x squared plus 15x minus 21, okay? So according to this, in theory, that polynomial at the bottom should be the divisor. So 6x squared plus 15x minus 21 should be the same as 2x squared plus 5x minus 7. Well, they're clearly not the same, right? So what did we do wrong? Well, sometimes we actually need to do a little bit of interpreting with our results, okay? And this is a case where we do need to interpret, which is why I wanted to do it first. So here's what we need to interpret. We need to ask ourselves, was there a coefficient in my divisor, okay? If that coefficient is not 1, then in order to get your quotient, you need to divide whatever you get by that leading coefficient. Okay, so this is the leading coefficient of the divisor. And this is our almost quotient. Okay, almost, because we need to divide by 3 before we get our actual quotient. So 6x divided by 3 is 2x squared. Okay, 15x divided by 3 is 5x. And 21 divided by 3, or negative 21 divided by 3, gives me 7. Now, let's see. Does this quotient match our quotient that we got using long division? All right, they sure do match. I've got 2x squared plus 5x plus 7, minus 7 for both of them, okay? So that's how you identify the quotient. And then this is also, we've got our remainder from earlier, okay? So because the remainder was not 0, we knew that 3x minus 2 was not a factor of 6x cubed plus 11x squared minus 31x plus 15. And so then we had to specify the quotient and the remainder, right? Quotient is the whatever we get at that bottom line, but sometimes we have to divide by that leading coefficient. And the remainder is going to be that one in the pink, the last number in your synthetic division process, okay? So the process itself is not too bad, but it's really important that we understand what all the different pieces stand for, okay? That interpreting your results is so, so important. All right. So that being said, here's what we're going to do to finish off the video. We're going to take a look at examples 5, 6, and 7, and they all ask the same thing, okay? So when I look at 5 and 6, I notice that the leading coefficient of that divisor is 1. So I don't really need to do anything special for those, but what I am going to do is go ahead and highlight this 2 right here in example 7, because in example 7, we're going to have to divide by that 2 like we did with the example number 4, okay? All right, so example number 5. Is x minus 3 a factor of 5x squared minus 3x minus 36? If it is a factor, indicate the factorization. If it is not a factor, specify the quotient and remainder. All right, so let's set up for synthetic division, okay? So the number that is going to go inside here is going to be what number makes x minus 3 equal to 0? And this is a pretty straightforward one to solve. We get x equals 3. 3 goes inside that little right angle thing. Okay, what about the numbers after that? Well, I've got these coefficients that I need to take. 3, 5, negative 3, and negative 36. Okay, so 5, and negative 3, and negative 36. All right, so we're going to skip a line, and then we're going to draw a line. And the first thing we're going to do is bring the first yellow number straight down. And then we're going to multiply. 3 times 5 gives me 15. And then we're going to add negative 3 plus 15 gives me 12. I got to do this one more time. I'm going to multiply. 3 times 12 gives me 36. And then I add, and negative 36 plus 36 gives me 0. Now, as soon as we get into section 3.6, you're going to realize when you get a 0, that's like the best news of your day, okay? So when you get that last number equal to 0, it means that x minus 3 is a factor of the polynomial 5x squared minus 3x minus 36. Okay? So now our directions are a little different. It says if it is a factor, indicate the factorization. So what I mean by that is we can say that 5x squared minus 3x minus 36 equals to x minus 3 times whatever I get down here. But it's not 5 and 12 and like it's 17. Remember, those stand for something. So the 12 is the constant at the end. And the 5 is the coefficient for the linear term. So really, 5x squared minus 3x minus 36 equals x minus 3 times 5x plus 12. And if you were to FOIL this back out, you would get what you started with, okay? So this is what I mean by indicate the factorization. I want you to write out what the factors are, okay? And so this right here would be part of our final answer, all right? All right, let's try another one. Is x minus 2 a factor of x cubed plus x minus 10? If it is a factor, indicate the factorization. If it is not a factor, specify the quotient and remainder. All right, so let's set up for synthetic division. We know that the number that goes inside of this is going to be the number that makes x minus 2 equal to 0. And I think that one we can kind of do mentally. If we put a 2 in for x, 2 minus 2 gives us 0, okay? And then we're going to pull the coefficients from our polynomial. So 1, 1, and negative 10, okay? But here's what I want us to do. If we just take these coefficients, 1 and negative 10, and we skip a line and draw a line, okay? This would actually be the wrong setup. 2 exclamation points. This is 100% the wrong setup, okay? So let's talk about why. This is a common mistake. This part is good to go, okay? But let's look at our polynomial here. I have x cubed plus x minus 10. Now, I notice that there's an x cubed and an x and a constant, but there's no x squared. Okay, let me say that one more time. There's an x cubed, an x, and a negative 10, but there's no x squared. Well, we can't just be like, oh, there's no x squared. X squared chose to not show up today, so we're just going to leave it out completely. We need a placeholder for it. So we can put the 1 for the x cubed. But we need to put a 0 for the x squared. And then we can put the 1 for the x and the negative 10 for the constant, okay? So I'm gonna go ahead and highlight this. Ooh, I'm running out of colors. This one, okay? You need placeholders, okay? So if there's a power that's missing, you need to put a 0 in its place. Can't just ignore it. You have to acknowledge that there is something there, but it's times 0. Okay, now we can do our synthetic division, okay? So we're gonna take the 1, bring it down. That was my first yellow number, right? Because these are yellow, kind of yellow, yellow, yellow. Then I'm going to multiply. 1 times 2 gives me 2, and I'm going to add. 0 plus 2 gives me 2. And then I'm going to multiply. 2 times 2 gives me 4, and 1 plus 4 gives me 5. Okay, one more time. 2 times 5, that gives me 10. Ooh, negative 10 plus 10 gives me 0. Now that is so good, right? And again, you'll appreciate this more when we get to 3.6, but getting 0 as a remainder is awesome because this means that x minus 2 is a factor of x cubed plus x minus 10. Okay, so it is a factor. Now, since it's a factor, we have to indicate the factorization, or we have to write out the factorization. What that means is x cubed plus x minus 10 equals x minus 2 times, remember these numbers 1 plus 1 and 2 and 5, these numbers, they actually stand for coefficients. So it's 1x squared plus 2x plus 5. And so we have factored a cubic function that before synthetic division, we couldn't really factor. It's really hard to know, like, kind of guess, like, what numbers go into it, okay? All right, let's take a look at one last example here. Is 2x minus 3 a factor of negative 6x cubed plus x squared minus 4? If it is a factor, indicate the factorization. If it is not a factor, specify the quotient and remainder. Now, this one, I think, is the trickiest one out of all the examples, and here's why. At the end, we have to remember to divide by 2 if we get a quotient, okay? We also, over here, we're gonna need a placeholder for the missing linear term. There's an x cubed, there's an x squared, there's a constant, but there's no x. So we're gonna need a 0 when we set up our synthetic division to make up for that, okay? Okay, so let's do this. We'll do the wrong setup and then we'll do the right setup, okay? So the wrong setup would be, let's see, what number makes 2x minus 3 equal to 0? Okay, I'm gonna add 3, I'm gonna divide by 2. Okay, so that's where I'm getting 3 divided by 2, 3 halves, okay? Now I'm gonna line up the coefficients in the wrong way. -6, 1, and -4, okay? So this is the wrong setup. Right? Double exclamation point. We did not leave space for our linear term. So we can keep the 3 halves, but we need a -6, a 1 for the x squared, a 0 for the x, and the -4. Okay, so this is that placeholder that we talked about earlier. After we've double checked our coefficients, we're going to skip a line, draw a line, and we're going to bring that first number down, -6. And we multiply. 3 halves times -6 is going to give me 9. And then I'm going to add straight down, which will give me 10. And then 3 halves times 10 gives me 15. And then I can go ahead and add, and I get 15. And then I'm going to do this one more time. 3 halves times 17, 3 halves times 15. Well, that's going to give us 45. Oops. 45 over 2. And I don't know what it is, but this is not 0 when I subtract them. Okay? So this is not 0, which means that 2x minus 3 is not a factor of -6x cubed plus x squared minus 4. Okay, so it's not a factor. Well, if it's not a factor, you don't need to indicate the factorization. But if it's not a factor, you need to specify the quotient and remainder. So here we go. The remainder, well, we already found, well, we didn't find it. I guess we should do that out. Let's see, -4 plus 45 over 2. Well, if I want to add those, I need a common denominator. So -8 over 2 plus 45 over 2. And then 45 and -8 make a 37 over 2. So 37 over 2 is our remainder, okay? Now let's find our quotient. So our quotient is not -6, 10, 15, okay? That's not what it is. Those numbers stand for something, right? The 15 is the constant, the 10 is the linear, the -6x, or -6 is the x squared. And then we have the plus and the plus, okay? But that's not the quotient either, because remember I said earlier at the end, we need to divide by that number, or the coefficient of the divisor. So I'm going to take this, I'm going to divide everything by 2, and that will give me the quotient. So -3x squared plus 5x plus 15 halves. This is my quotient for this particular division problem, okay? So it's not a factor, but it doesn't mean there's no answer. It just means we're looking for different information, like the remainder and the quotient instead of the factorization, okay? All right, so I hope you found that video helpful. Please bring questions that you have to class on Wednesday. Okay, so we're meeting again on Wednesday, September 9th. If you have questions, please bring those. We'll go over this very briefly at the beginning, but we're gonna spend most of our time in 3.6, okay? All right, folks, I will see you on Wednesday.